This is a bonus video on 4.1 finding antiderivatives, so no need to take notes on this. This is just if you want to have extra practice or maybe see a couple of more examples. You can tell my graphics are starting to really get fancy here. I spent all of 15 seconds coming up with this. So in this example, I'm starting at the second derivative stage, and I want to work my way all the way back to the function and find a particular solution. So if I want to start at the second derivative stage, that means that if I take an antiderivative of a second derivative, I'm going to end up at the first derivative stage. Alright, so I take the integral of my second derivative, which is x squared plus 3 cosine of x dx, and apply the power rule. This is going to be x to the third all over 3 plus, now the antiderivative for cosine is going to be a positive sign, so plus 3 sine of x plus my arbitrary constant is going to be a c. And notice they give me a initial condition regarding the first derivative, so I'm going to use this one to solve for this c value. So I'm going to apply the initial condition f prime of 0 equal to 3. Alright, so when I take 3 f prime of 0, that's going to be plugging in 0 into this, so 3 plus 3 sine of 0 plus c. That's all going to equal 3. Well, turns out this becomes 0. This is also 0. So really all what I have left over is c is equal to 3. So f prime is x to the third all over 3 sine of x plus 3. Now I want to work my way back all the way to the function, so I have to take one more integral. If I take the integral of f prime, I end up with f of x, so that's going to be the integral of x to the third all over 3 plus 3 sine of x plus 3 dx. Alright, so then I have to apply some power rules here. Okay, so this becomes x to the third plus 1 becomes x to the fourth all over 3 times 4. I'm going to explain why that is in a minute. Plus antiderivative of sine is a negative cosine, so it's going to be a plus 3 multiplied by negative cosine of x. Antiderivative of 3 is 3x plus c. This over here on the first term, if I had x to the third all over 3, it's kind of the same thing as saying 1 over 3 x to the third power. And so when I applied the power rule, it became 1 over 3 x to the 4 all over 4, which is the same thing as just saying x to the 4. I'm going to multiply the denominators 3 times 4. So that's how I got from here to here. Is I kind of bypassed pulling out the 1/3, applying the power rule. So simplifying this, I'm going to get x to the 4 over 12 minus 3 cosine of x plus 3x plus c. This is what my function is. And now I need to apply another initial condition, which is up here. So this initial condition that I have is now f of 0 is equal to 2. So when I plug in f of 0 into my antiderivative, it's 0 to the 4th all over 12 minus 3 cosine of 0 plus 3 0 plus c. That's somehow going to all equal 2. Well, more stuff cancels out. This becomes a 0. This stays as 1, so I'm going to leave this alone. 3 times 0 is a 0. Cosine of 0 is 1 times negative 3 is negative 3 plus c. So So 5 is equal to a C. So my particular solution is going to be f of x is what I got here with the C value of 5. So x to the 4th all over 12 is 3 cosine of x plus 3x plus 5. Alright, now for this bonus video there is a U-try, so I'll put up the problem just 1 second. So here's the U-try problem. Let me move all this stuff out of the way. So give you a moment to pause it. You start off kind of the same thing. Second derivative, they give you some information about the first derivative and the function, and they want you to find a particular solution. So go back all the way to the function. Alright, so now that you've tried the problem, here is the answer. And if your answer didn't quite match this, I can go over with you in class while I'm checking the notes, or while visiting with your individual group. But this is the particular solution to the previous problem, and that's it.